Alright, let's read some Kingfisher about light. So this is page 260 and 261 in Kingfisher. Please follow along with me. Light. Light is a form of electromagnetic radiation that can be detected by cells in the eyes of animals. Light can be scattered, reflected, refracted, and diffracted. Light is a form of electromagnetic radiation. The wavelengths of visible light are shorter than those of radio waves and infrared radiation, but longer than those of ultraviolet radiation and X-rays. Each color of light has its own special wavelength. Visible light affects animals. I've got to pause. A wavelength. It assumes we know what a wavelength is. So the length of a wave, here I'll draw two. They're not beautiful, but okay. The length of a wave, so here light moves in a wave. The length is from, so notice they have high mountaintop peaks, those are called peaks, and then little bottoms that are called troughs. The length between two of the highest points is how long a wavelength is. So this wavelength is a lot longer because there's more space between the high points than here. So light, the light that we can see, has a shorter wavelength than radio waves, so like what we hear on the radio, and infrared radiation, but longer than ultraviolet. Ultraviolet is like with the sun, UV rays. I don't know if you've ever heard of UV rays. The sun emits those and they can be harmful in large quantities to us, so sunscreen protects usually against UV rays, if I'm not mistaken, and X-rays, so when you go and get an X-ray. Okay, so each color of light has its own special wavelength. Each color has a different length between its two peaks and its two troughs. Visible light affects chemicals in the nerve endings of the back of the human eye. These nerve endings then send signals to the brain, which interprets the signal as light. Nothing travels faster than light. Its speed in a vacuum, so in outer space, is about 186,000 miles per second. So light travels slightly slower through materials such as air, glass, or water. So when we talk about light years, how long it takes light to travel in a year, think how far that is. If it travels 186,000 miles in 1 second, it's crazy to think how fast it or how far it can go in a whole year. Beams and rays. Light travels from its source as a series of electromagnetic waves. Scientists find it convenient to draw arrow-shaped lines called rays that show the direction in which these light waves travel. A beam of light consists of groups of light waves that all travel in roughly the same direction. The beam of light from a flashlight spreads slightly as it travels. The light appears fainter as distance increases, since its light waves are spread more thinly over a wider area. The beam of light from a laser has almost parallel sides. This means that the light waves hardly spread out at all as they travel. This is why the beam from a laser can travel enormous distances before it becomes too weak to be seen. So here down at the bottom you have the visible spectrum of color. So let's read this right here. Visible light forms a spectrum of colors that range from red at longer wavelengths to violet at shorter wavelengths. The wavelength of infrared radiation is longer than visible light, and the wavelength of ultraviolet is shorter. The human eye cannot detect infrared or ultraviolet radiation. So that in the middle, I can point to you. So this right here in the middle is what we can see. These wavelengths are too long for us to be able to see, and these are too short for us to be able to see. Okay, scattering. We see light only when it travels into our eyes. We cannot see a beam of light that travels past us through clear air. Light beams become visible when air is foggy. This is because the tiny water droplets in fog reflect some light out of the path of the beam. The light scattered to the side of the beam enters our eyes and makes the beam visible. The microscopic particles in smoke can also scatter light. Solid substances that scatter light are said to be translucent. Waxed paper lets light pass through it, for example, but scattering disorganizes the light rays and prevents a clear image from being seen. Transparent materials, such as glass, allow light to pass through them without scattering, so a clear image can be seen. So if something's transparent, light comes right through it like normal. So like a window is transparent, you see right through it. But if something is translucent, it still kind of scatters it a little bit and makes the light look funny or foggy. So think about, wax paper, putting it in front of a flashlight and things. It wouldn't come through as clearly as it would through a window because there's some scattering. Reflection. Few visible objects produce light. Most are visible because they reflect some of the light that falls on them. Some objects appear bright or shiny because they reflect most of the light that falls on them. Objects that are bright but matte, scatter the light that they reflect. Mirrors produce clear images because they do not disturb the arrangement of rays as they reflect. Dark objects absorb most of the light that falls on them and change it into heat. That's why people usually say don't wear dark colors on a really hot day, because black absorbs most of the colors that we see and turns it into heat. It doesn't really reflect any colors. But other colors, so what causes color, I'm not sure if this is going to talk about it. What causes color is what colors or what wavelengths are absorbed in something versus what's reflected back. So if something is, here I've got your math book, it's blue. That's because the color we're being reflected back to your eyes is blue, but all the other colors are absorbed. So black absorbs all colors and changes them to heat, and what's reflected back is black. It's a little confusing, but I bet we get into color maybe next week. Okay, and I know Bill Nye talks about it in his video tomorrow. Okay, refraction. Light waves slow down when they move from air into a denser substance, such as glass or water. The speed of light in water is 3/4 of its speed in air. If a ray of light enters water or glass at an angle, it changes direction slightly. This effect, called refraction, causes lenses and other transparent objects to alter the appearance of things seen through them. Diffraction. When light waves pass through a hole or slit that has a similar width to their wavelength, they spread in all directions as they emerge. This effect is called diffraction. Waves that spread from separate openings can interfere with one another. Depending on the direction, some of the waves cancel each other out, and some reinforce each other to produce patterns of light. Infrared and ultraviolet. Over 200 years ago, scientists performed a simple experiment to show that light is a form of energy. They used a glass prism to split sunlight into a spectrum of colors, ranging from red through green to violet. Then they shone each color in turn onto the bulb of a thermometer. The thermometer showed an increase in temperature as it absorbed energy from the light. The thermometer showed the presence of invisible infrared heat rays outside the spectrum in the dark space next to red light. Later, photographic film showed the existence of invisible ultraviolet radiation in the dark space next to violet light. So, a lot going on there. Trying to see if we need to read anything else. You can feel free to read on your own the little things, the little subtext under pictures. And I hope you enjoy learning more about light and color this week.